Hi and welcome. Today we'll be creating a blast wave using line renderer and physics.overlap sphere. The effect that we'll be creating will look something like this. It will start from center and slowly move towards the radius, the maximum radius that we have
Welcome
specified.
to Vinex Studio. Let's start making games.
To start with, I have an empty scene here with some cubes, and the plane's mesh renderer is basically hidden so that we'll be able to see the line renderer properly. And all the planes and the cubes have a collider and a rigid body attached to them. The plane's rigid body is set to kinematic so that it doesn't fly off because of the force. Now what we'll be doing is we'll be creating a line renderer and we'll set the values of the line renderer's position around a circle and we'll slowly increase the radius of the circle to the maximum value that we want. So first we'll see how to set up the line renderer and how to slowly increase the radius of the line renderer so that a blast effect is created. Then we'll use the physics.overlap sphere to find the objects around the blast radius and add a force to them so that they fly out. So let's go to the hierarchy, click on the plus sign and let's create an empty game object. Let's call it blast and let's reset the position to origin. Let's create an add component and let's add a line renderer. As soon as you add the line renderer, make sure you uncheck use world space. This is required to update the line renderer's position during gameplay. Otherwise, it will not get updated. The next thing that is required to be done is to set a material to the line renderer. If you don't have any material, then you can download some from Unity Asset Store. I have a material made for it. So I'll just drag and drop the material to the line renderer. And there's no other setting to be done in the line renderer because we'll be doing everything using the script. We can just disable the line renderer and let's go ahead and add a script. Let's call it blast script. Now let's open the blast script in Visual Studio for editing. Now we don't need these two using statements, so let's remove them. So let's go ahead and add our variables. The first one that will require is a line renderer variable. Let's call it LR. Next, we'll read the radius. So radius will be a float and it will start from 0. So we'll set it to 0. Next, we'll need float width of the line. So let's call it line width and let's set it to 3. Next, we'll need the number of points in the line renderer. So it will be an int. So we'll call it point count and let's set it to 30. So you can increase the number of points so that the line renderer looks smooth. Next, we'll need the angle between each of the points to calculate the position. So we'll call it angle between points. And we'll just set it to 0. Then we'll calculate the positions and we'll store them in a vector 3. So it will be an array. So we'll create a vector 3 and it will be an array. We'll call it positions equal to new vector 3 and it will be of size which will be equal to your point count, which is 30. Now in our start function we'll just say lr dot enabled equal to true. So our line renderer will be enabled when this game object is activated. The next one is we're going to say line renderer dot position count, that is the number of points, equal to our point count. So now we are setting the number of points to our line renderer. The next is the angle between points, which will be equal to 360-degree, that is the total circle, divided by number of points, which is points count. So say if you have 10 points, the degree between each point will be 36 degrees. And if you have 30 points, the degree between each will be around 12 degrees. So now you have the degree between each. So you can get the x and y, x and z position because we need the blast to go in the flat plane, the xz plane. So you can get the x position using the sine of the angle and you can get the z position using the cos of the angle. Now we need to do that for all the points. So we'll use a for loop for int I equal to 0, and we'll say I less than point count. And since the last value will also be equal to the first value, so we don't need to set that value here. So we'll just subtract 1 from here, and we'll increment I by 1. So now the first thing that we'll do is we'll find the angle from the initial position to the current point's angle. So if you're in the third point, then it will be 3 times the angle between each point. So we'll have another float angle which will be equal to your angle between points multiplied by your I, and that we need to convert that into radians so that we can use it to find the position. So we'll say math dot degree to radian. So now that we have the angle, now our position of I will be equal to mu vector 3, and in the x it will be math dot sine of your angle, and the y will be set to 0, and the z will be math dot cos and angle. So now all the positions will be set except for the last position. So after the for loop, we'll just say positions of point count minus 1, which is our last position, is equal to positions of 0, which is our first position. So now our first position and last position is the same, so we'll be able to form a complete circle. Now for the sake of clarity, we can just put this whole point finding thing into a different function. We'll call it void find points, and we'll put the whole thing inside the find points, and we'll just call find point. Now all the positions that we have got are in unit vectors because we have just done the we just found the angle and we have taken the cosine of those angles. Now we'll multiply that with the radius to slowly increase the size of the circle. Now before we multiply and set the position, we need to increment the radius every update. So we'll just be saying radius plus equal to time dot delta time. Now this will be very slow, so we'll just add another factor which will be our speed, float speed, and we'll set it to something like 10 as of now. So we'll make it a public variable so that we can change it from the inspector, and we'll multiply speed with time dot delta time, and we'll increase the radius after we set the positions of our line renderer. That is because we need to set the initial position to a 0 position. So we'll create a function which will be void set positions, and all that it will do is it will create a for loop for int I equal to 0, I less than points count, and I plus this. So here we'll be just saying lr dot set position and I comma positions of I multiplied by radius. That's it. So all that we have to do is we have to call the set position here in the update. So now we are setting the position, then we are incrementing the radius, and then again we are calling the set position in the next update. So depending on the speed of increase of our radius, the blast will slowly move towards the outer direction. Now this is just the visual part, so we'll just confirm if it is working, then we'll come and program the remaining force part of the code. So let's go back to Unity. So if we play the game now, Okay, we have an error. So let's see what is the error. So I forgot to get the component. So LR will be equal to get component line renderer. So now we should not get the null reference error. Let's go back to Unity and let's play the game. So yeah, we see a blast going. So as you can see, it is going on continuously and it is not slowing down. That's because we have not set a max radius. And you can also see the thickness of the line renderer is not reducing. So what we can do is we can slowly reduce the width of the line renderer so that it becomes 0 when it reaches our max radius. So that way the blast will basically disappear at max radius. So now we need a few things here. The first one will be float max radius. So let's set it to maybe 30. Now in our update, we'll just say lr dot width multiplier is equal to. So we have to reduce it from 1 and make sure it reaches 0. So we can just subtract the max radius from our current radius and set it to the multiplier. So that way, when the radius is equal to the max radius, the multiplier will become 0 and the width of the line renderer will also become 0. And now to make sure that the line renderer is not rendered after the radius has become greater than the max radius, we can just use an if statement where we'll check radius is less than max radius. We can say less than or equal to because we need the multiplier to become 0. Okay, and we'll just set here. Okay, so now we have an if statement which checks whether the radius is less than the max radius. If that is the case, then we'll set the position and the width multiplier will slowly become 0 as the blast radius increases. So now let's go back to Unity and see if that is the case. So let's play. Oops. Something was wrong. That's because the width multiplier basically became so big because max radius set to 30, the initial value of the multiplier would have gone to 30. So you have to say this whole thing should be divided by the max radius so that the initial value is 1 and as soon as the radius is increasing, the value will become 0. So let's play the game. Okay, so you can see that the line renderer started from the center, and as it approached the end, it was almost equal to 0. So now we have the line renderer effect. Since it's a blast and not a wave, it has to be faster. So we can increase the speed value to something like 40. And now if we play our game, so this is much better. It looks like a blast. And if you want the blast to be continuous, that is when one wave is over, you want the next wave to start, you just have to set the else statement which resets the radius to 0. So now if we reset the radius to 0 and if we start our game, so you can see that the blast starts from the center and keeps on going. So this is a very cool effect. We can also use it for creating a radar, a sonar kind of thing. So you can use a better material and a better texture to create a better looking effect. So I think we don't require the line width parameter, so we can remove that. Now the visual effect of the blast is set, but the blast is not doing anything to the objects around it. So for that, we'll be using the physics.overlap sphere, which will find the colliders around in a particular radius and apply a force to them using rigid body. So we'll require a array of collider. So we'll just say colliders and we'll call them col. Then we'll have the rigid body RB. Now, as soon as you set the position, the next one will be to find the game objects. So we'll create another function. Let's call it void apply force. Now inside the apply force, we'll just say call equal to physics dot overlap sphere, and we have to give the position, which will be your transform dot position, and then you have to give the radius, which will be equal to the current radius. And once you find the objects, which will be basically a list of objects inside that, so once we do that, we'll just have to say for each variable I in call, so we'll just say I dot game object dot get component rigid body. So we'll get the rigid body component of that, and we'll add a force, and the force will be a vector 3 force, which will be the difference between the current position of the game object and the origin of the blast. So that will give you a direction. So we'll just say I dot transform dot position minus transform dot position. So this whole thing should be multiplied by a variable called force value, and then the force mode will be set to impulse. So now we have not set the force value, so we'll just go ahead and create a variable float force value equal to, let's have a small force 1. Okay, so yes, semicolon here. So we'll just find the game objects, and then we'll get the rigid body from those game objects and add a force to it. And we'll set the position and then call apply force from our update function. Since this is all physics, we'll do it in fixed update. So I think that's it. Now if we go back to Unity, and all the cubes here have rigid bodies attached to it. So let's go ahead and play the game. So yeah, the cubes flew off. Now we can also create the inverse effect by reducing the radius and changing the direction of the force. So that way all the objects around it will be attracted to the center. So it is, if you want to create that, you can just go to the code and make sure you change the direction of the force here, where you subtract the transform dot position from the object, and to the blast radius you just change the position of these two, and then rather than starting from 0 and incrementing the radius, you have to start from a bigger value, that is your max radius, and reduce it till it becomes 0. So that way you'll also get a cool effect, and everything will be attracted towards the center. So that's it. If you like this tutorial, press the like button below, and if you have any other questions, feel free to comment below and we'll answer them for you. Thank you, and see you in the next tutorial.
Thanks for watching. Don't forget to like, subscribe and share.